Hi guys, and welcome to Physical Sciences for Year 10 of the Australian curriculum. This is going to be an explanatory video where we're going to be looking at the energy, gravitational potential energy, or GPE. Okay, now gravitational potential energy is defined as the energy which is gained on an object as we raise it up through a certain amount of height above the ground, above the surface of the Earth. So basically, if I take this pen and lift it off the computer, I've given it gravitational potential energy. Okay, now the word potential means it's stored. It has the ability to release that energy, but doesn't necessarily happen. So if I move it up to this point here, it's got a certain amount. It has the potential to be converted into another type of energy. And that's the key thing to understand when we talk about potential. When we talk about academic potential, it's what's inside you. It's the type of intelligence and skills and talent that you've got inside you, but it's not necessarily going to be released. So when you look at the next few sets of energies that we're looking at, we're going to be looking at the potential energy. Now, a machine is going to try and convert potential energy into another form. And obviously, the more efficient that machine is, the more will go from that potential energy to that desired energy that we want to have. Now, obviously, what is it that determines the potential energy that you've got in an object when you lift it above the ground? Well, it's all down to the concept of gravity. Gravity is the force which is going to be pulling down the object. Now, it follows through Newton's second law, which we're going to be looking at in the motion section. But Newton's second law says a force is going to act on a mass, and the result is it's going to change its speed. Now, if you change its speed, it's sitting here at 0, okay, but as soon as I drop it, it's going to start gaining speed, okay, so it's a change in speed. As a result, it's an acceleration. Newton's second law says F, the force of gravity, equals the acceleration or the change in speed of an object. Okay, now the force that we've got on the planet Earth is around about 10 meters per second. We can change the speed by 10 meters per second every second. Okay, so the higher we take our object up, within reason, the more energy we're going to gain, because we're going to get more acceleration of the object. Okay, so what we need to understand is that we've got an object. Now the object has a mass. Okay, it's raised above the ground. The higher it's raised above the ground, the more time it has to accelerate to a faster or to more energy, or it's converted to more energy under the influence of gravity. So, as you can see in the writing here, which has been taken from the iBook, basically increasing the height above the ground means that gravity has the effect of pulling it down. So, as soon as you raise it, gravity will pull it down. Obviously, we're going to have to do work to put it up to a specific height. Okay, so we'll get to that concept of work again, having to be put in. We actually have to put energy in to give it gravitational potential energy. It's like climbing a ladder. If you climb a ladder, you actually have to use chemical energy to get up the ladder to gain gravitational potential energy. So we have to do work to gain gravitational potential energy, or GPE. There are 3 variables which are going to be involved in calculating the amount of gravitational potential energy we've got. It's the mass of the object, okay, how much matter we've got, the height that we're going to raise it, and also the acceleration due to gravity, or G, that's given the symbol G. So mass is given the symbol M, height that it's raised above the ground is given the symbol H, and the acceleration due to gravity is given the symbol G. G, gravity, makes sense. Obviously, we're on different planets. We're going to have different amounts of gravity. Most of the examples that we're going to be looking at is going to be looking at planet Earth, and we're going to be at a fairly similar height when we're talking about gravitational force. Now, remember, as you get further out towards the outer limits of the atmosphere, there's going to be less gravitational pull. But generally, we're going to be stating that everything that we're talking about is close to the surface. So within a few kilometers of the surface, height-wise, is the change in gravitational acceleration is going to be very, very negligible. Okay, so what's going to happen? As I stated, as we increase the height, we increase the GPE. So the further up you go, the more GPE. If you go up and start eating food, you're going to increase your mass. Increasing your mass is going to increase your GPE. If we were able to have a dial to change the force of gravity, by increasing the force of gravity, we would increase our GPE. And vice versa, obviously. Decreasing the height, decreases GPE, decreasing the mass, lop an arm off, decreases your GPE, or decreasing the gravitational pull. So if you went to the moon and went up a certain height, your mass would be the same, the height would be the same, but the gravitational pull of the moon is very, very small. It's only like 1.6. Then the result is you're going to get decreased GPE. Okay, so let's have a look at this guy here. He's in Surfers Paradise on the Gold Coast, and he's jumping off a high rise on the bungee. And basically, what he's done by going up, he goes up in a winch, or goes up in a cage, and the result is he has gained gravitational potential energy. That is going to be converted into kinetic energy on his way down. Okay, it will then be converted into elastic energy as the rope stretches, and we'll talk about that later on. But you can see he's high up. The result is the fact that he's high, he's got a mass, nothing's lost. So he's got his mass, he's got his height, and the acceleration due to gravity will be the same. So as a result, he will have a specific amount of kinetic energy. Look at this scenario. This is the Terra 2 at Dreamworld, again on the Gold Coast. And what happens here is the car is basically shot up a large ramp. Now, as it's shot up, it's accelerated. Okay, so it's got lots of kinetic energy as it's shot up the slope. Now, as it goes up the slope, and you can see the tower that you've got there, as it goes up the tower, the result is it's got gravitational potential energy. That kinetic energy is being converted into gravitational potential energy. The car has mass, the mass doesn't change. The height will change, so the further up they go, the more gravitational potential energy they're going to get because of that H system. The gravity will be the same. So gravity is the same, the mass is the same, but the height is changing as it goes up the slope, which means that the gravitational potential energy is increasing as it goes up the slope. Eventually, all of that kinetic energy will be converted into maximum GPE, and that's the maximum point on the track at the top of that tower. Then, of course, gravity is going to grab hold of it and pull it back down again. Then that gravitational potential energy will be converted into kinetic energy. And you pay for that physical concept, or to experience that physical concept, when you go on any fun ride. Okay, and we'll talk about those in a little bit more detail, and I've got some video shots of various roller coasters, and we're going to run through those roller coasters and talk about that conversion from GPE to kinetic energy. Okay, so the next question is, how do we calculate GPE? Well, GPE can be calculated with a very, very simple equation. The gravitational potential energy, as you can see in red here, equals the mass of the object multiplied by the acceleration due to gravity multiplied by the height that it is above the ground. Now remember, it's vertical height. Okay, it's not the distance that you go up a slope, it's the vertical height above the ground that's going to pull you down. So it's mass times gravitational acceleration times the height. Now GPE is an energy, so it's measured in joules. The mass must always be in kilograms. The acceleration due to gravity is meters per second. Now that can be written as m/s/s or ms to the -2. Okay, so you may see it in two different forms. Make sure that you're aware of it. I've put it in the note at the bottom so that you can see the two forms. And then h is the height above the ground, which is always measured in meters. So again, if you're in kilometers, you need to convert into meters. And likewise, if you're in, for the mass, if you're in grams, you need to be converted into kilograms. The equation only works with those units, so bear that in mind. Now, as I've stated here in brackets there, the acceleration due to gravity on the planet Earth is always classified as 10 meters per second, which can be written as 10 ms to the negative 2 or 10 m slash s slash s. It's always the same. However, if you want to be more specific, the actual value is 9.81. Okay, now in most cases 10 will be used, but you need to read your question or your exam paper and then make sure that and look for what it says for g. It may say g is going to be used as 10 meters per second, or let g always be 10 meters per second, or it might say let g always be 9.81. So look for that in the questions or at the front of the paper, and then you won't go wrong. So let's run through a little example so that you can practice, and then there's some exercises that you can work on. So in this example problem here, we've got to calculate the gravitational potential energy of a 5 kilogram mass on Earth, where g is 9.8 meters per second, when the mass is 20 meters above the ground. So we've lifted a 5 kilogram mass 20 meters above the ground. What's the gravitational potential energy? So write down what you know, and you can see here I've done it in the same sort of format. After a while you'll get really good at this, but it's always worth going through the question and highlighting what you know. Calculate the gravitational potential energy, so GPE question mark. What do I know? Well, I know the first piece of information is the mass, which is 5 kilograms. Because it's in kilograms, I don't need to convert it, so that's good. The height is 20 meters. Okay, it's in meters, don't need to convert it. And finally, it states that I've got to use g as 9.8 meters per second. Okay, so 9.8 meters per second, or ms to the negative 2, or m slash s2, all works, it's all the same. Okay, so all I have to do is substitute that into the formula. So write down the formula. GPE is m times g times h. So it's 5, the mass, times the acceleration due to gravity, 9.8, times the height that it's been raised, which is 20 meters. Comes out at 980 joules. Okay, so very, very straightforward. Just follow the process that we've gone through here and you won't go wrong. So what I'd like you to do is, from the iBook, is go to exercise 1.3 and run through. There's some questions there for you to run through. The answers again are in the keynote presentation towards the end of that section. It tells you where the answers are so that you can go through and practice them. Okay, well, I hope that's explained gravitational potential energy and how it works. Join me again. We'll look at another type of energy. We will be touching on GPE again when we look at energy conversions and transformations, etc. Okay, so thank you for watching, and look forward to seeing you soon.